Example, translation, rotation, or reflection. This is definitely a translation. Okay, let's just look at point A. Point A is originally at -3, 10. A prime is at 6, 3. So since this is a translation, we know it deals with X and Y. Well, it's going to the right and down, so that means we're going to add to the X's, but subtract from the Y's. And I'm going from -3 to +6. I'm adding 9. It's going to be X plus 9. And I'm going from +10 to 3. We're subtracting 7. Okay, let's talk about line of symmetry. Line of symmetry is just the line that you can draw or sketch in that makes the picture symmetrical. If I took that picture and I folded it on that dotted line, the shape would fall exactly on top of itself. But then we have a thing called rotational symmetry. Rotational symmetry is when you can take a shape and you can turn it so it maps directly back on top of itself. So if I turn this shape 45 degrees counterclockwise, it doesn't look the same as the original. So here's your original. This doesn't look the same, so that's not going to work. But if I rotate the figure 90 degrees, it looks exactly the same as figure number 1, so that works. If I turn it 180 degrees, it looks exactly like it did at the original. If I turn it 270 degrees, it looks exactly like it did originally. And then we could turn it again to be 360. So what happens is this thing has rotational symmetry in 90-degree increments. So if I want to find the magnitude, it's the degrees in which the map's onto itself. We can take 360 divided by the number of turns. Typically, the number of turns is also the number of sides if it's a regular polygon. Since this is a square, we could turn it 4 times. So that's 360 divided by 4, which is 90 degrees. Let's try some examples. Okay, so let's state if it has line symmetry or not. Well, with this arrow, do you agree I could fold it in half down the middle and it would mirror on top of itself? That has one line of symmetry. Over here, let's try to cut it down the middle. If I cut this shape down the middle, it will be directly on top of itself. It's a mirror image. But I can also go down the middle this way. So this has 2 lines of symmetry. And then looking at this third example, there's no way I can't chop it in half like this or like this or like this. It doesn't work. So this has none. Think about a square. I can cut it vertically. I can cut it horizontally. But on a square, I can also do diagonally. Think about folding a napkin in half. It would make a triangle. And I can cut it diagonally this way. So a square actually has 4 lines of symmetry. State whether the figure has rotational symmetry. Write yes or no if located in the center. If so, locate the center of symmetry and state the order of magnitude. Okay. So if I turn this 180 degrees, so let's say this is the top. Think about holding your notebook or a piece of paper. If I turn that 180 degrees, this side will end up here. And if I turn it 180 degrees again, it will end up back by itself. That's 2 turns. 360 divided by 2 equals 180 degrees, which is the magnitude. Obviously, the center of symmetry is in the middle. So since this shape has 5 sides, it's a pentagon. It is a regular pentagon. What that means is it will go 5 turns because all the sides are the same, right? This side will end up here. That's 1 turn, another turn, 3 turns, 4 turns, 5 turns to get back to the original. To figure out the magnitude, we do 360 divided by 5. 360 divided by 5 is 72 degrees. On this shape, we're going to assume all the dots are equidistant apart, all the points. So what happens is, think about turning like a paper plate. If I put a dot here, I can turn it 1 turn, 2 turns, 3 turns, 4 turns, 5 turns, 6 turns, 7 turns, 8 turns, 9, 10, 11, 12, 13, 14, 15, 16 turns. To figure out the magnitude, we do 360 divided by 16. And that's approximately 22.5 degrees per turn. So the image on the right has blank lines of symmetry. However, it does not have rotational symmetry at all. Why? So how many lines of symmetry does it have? 1, right? If I cut this smiley face down the middle, it's a reflection of itself. It doesn't have rotational symmetry because of the eyes and the mouth. Here's your homework, assignment 2-2. Please open it up with Kami. You can download your annotations and upload the PDF to the classroom.